Yes, so today we will present our project VALET, which is a smart car parking system. Our presentation overview is first we will explain what is VALET and what is our motivation to make this project. And after that, we will show which hardwares that we use in our project. Then we will explain and show our code implementations for Arduino, Node MCU, and Blink application. And in addition to that, we will show these serial circuits of our project and our devices also. And after that, we will show a small example of our project working in a short video. At last, we will explain the main results after we develop the project and give our expectations about future of our IoT project. So, what is VALET? VALET is a project which is a parking sensor application that users can see available parking spots from different places. In order to do that, we use different devices and for each phase in our project. So, why we developed the VALET? We developed VALET because traffic is a huge problem in overpopulated cities like NYC, London, and other big cities all around the world. It can be a good solution for users who are living in crowded areas because it can take hours to find an available parking spot. With this application, users can save minimum 1 hour for each day, and it can be possible to save more than that at weekends. So our hardware, we have three different hardware components, and we connected these with jumper cables and to make the system work. So first hardware is Arduino Uno. We use Arduino Uno, which is a microcontroller board, to communicate with other devices in a sustained way. So our second hardware is the Node MCU ESP8266 Wi-Fi module, which shares the data in Arduino with the mobile application from Wi-Fi. And our last hardware is FC51 infrared proximity sensors, which is used for detecting and checking the availability of parking spots in our project. And for our system design, we actually use IR sensors to detect presence of any obstacle. So the sensors send the data to Arduino Uno, and after that Arduino is the microcontroller, so it shares the data with other devices like Node MCU. And Node MCU is the Wi-Fi module, so it has a big role to sharing the data with our Blink mobile application. So our Blink app is lastly shows the data clearly for our users.
Hello, everyone. And now I will talk about the platforms we use, the libraries, and also the tools. First of all, we use Arduino IDE since we used Arduino Uno in our project. We also use Arduino language for the programming language, which is based on majorly C and C++. Secondly, we use Blink application to produce a user interface. And we use Blink Arduino library. We set up that to integrate the Blink functions and features to our programs. We also used the header files. For example, one of them is software serial H. That makes our Arduino to communicate with all of the pins on it. And also we use ESP8266 Wi-Fi.h header file to use the Wi-Fi feature to transmit data to our user interface. Now I will go over our program implementations. First to start, we go with Arduino. This is the Arduino code we wrote. In beginning, we include our software serial age, as I stated, to enable the serial communication between devices. And also we declare the node MCU with parameters 2 and 3. And that means the node MCU is connected to pins 2 and 3 of our Arduino. And then we have some variable declarations and initializations. These are for to store the data, store the outputs from the sensors, received from the sensors. And these are for declaring which pin is connected, which sensor connected by which pin to our Arduino. For example, this variable means infrared sensor 1 connected with pin number 12, not 13, that's a typo. And then we have a string variable, lot status, to consist all of the data for a parking lot, the status of parking, all of the parking spots. In our setup block, we begin the serial communication and node MCU, and we declare our all pins as input since they send data to our Arduino. In our loop block, we call our function getOccupancy, which I describe later. In load status, we declare our outputs for all the sensors. This is our message actually to send to the node MCU. Here we print the whole message to serial monitor for debugging issues. And also we send it to the node MCU here. After that, in each iteration, we remove all the contents in the lot status to make it work. Finally, I will describe the getOccupancy function. It basically iterates all sensors to read and assign the appropriate values to corresponding output variables. It goes all over the sensors and receive data, and if it's equals to low with digital read, if it's equals to low, we assign it to 255, which declares the parking spot is full. And if it's high, equals to high, we declare it as 0, and it means it's empty. It works like that. And then the node MCU program will be analyzed here. I go to our node MCU program. We have some variables, some includes libraries, as I stated in our Arduino program. We have variables like character and message. These are to store data store and send data from sensors and to the LEDs in the Blink application. We have a token sent by Blink. We need to copy the token and paste it to our code to work it very quickly. And also we have to declare our Wi-Fi ID and Wi-Fi password to make Blink work. In our setup block, we begin the serial communication. We begin the Blink with our Wi-Fi ID, Wi-Fi password, and token. Also, we set a timer for our function. Then we have a function like split by delimiter. I will describe it later. In the loop block, we control that if there are serial communication available. If it's equals to 0, if there are no communication available, we keep running the blink and timer. Else, if we got a serial communication available, we just use serial.read function to read a character from the message sent by Arduino in each iteration. And also we update our message variable to combine the characters to produce the complete message sent by Arduino. If character equals to /n. That means if there are no characters left, we got to the end of the message. We just use split by delimiter function to split the whole message into 5 strings for 5 sensors. Then we convert it to integer here. We need to do it because let's only accept integer values to send. And we have functions here for each sensors. For example, this one value to LED1 function just assigns the converted LED1 variable to S data, and using virtual write function, it sends the converted data to the virtual pin V10. This V10 is assigned to the LED1 in the Blink application. We will describe it later on user interface. And that's all for our programs. For the user interface, as I stated, we use Blink. And Blink application, there are widgets to use to display the data sent by IoT devices. While starting to design our user interface, we selected Node MCU for our device, since Node MCU sends data to our application. And then we use 2 widgets. These are the LED widgets, and these are the tabs widgets. Navigating to tabs allows you to browse different parking spots in different locations, and each LED is representing a parking spot. So when we run our code, run our application, for example, if a car parked to the B2 spot, our application will show B2 LED on, like you see here. If LED is on, it means a car is parked to that parking spot.
So, as a conclusion, in today's world, there are different type of IoT devices that help people a lot, and our project is mainly about helping people to use their time an effective way in their spare time or in their working days.
I will show our demo quickly. That's our demo for our application. And we would like to thank you for listening us. I wish everyone a good spring semester, by the way.
Yeah.
And thank you.
Thank you again.